Tomorrow you're going to be doing a lab where you'll be finding the molar volume of a gas as well as trying to find the value of R, which is the ideal gas law constant. In order to know R, of course, you would need to know P, V, N, and T all at the same time of a gas. The gas we're going to be using is hydrogen gas, which will be generated as a product from the reaction of magnesium solid with hydrochloric acid. You're going to get the pressure, volume, moles, and temperature of hydrogen in order to find R. And then using those same P, V, and T, you will solve for the molar volume of hydrogen at STP, which is going to be V2. Hopefully you're going to get 22.4 for that. And of course, hopefully you'll get 0.0821 for the R value. The way you're going to do this is to be using a Udeometer. A Udeometer is like a giant test tube with graduations. So it's a very tall test tube looking like glassware, and you're going to have markings on it for volume. So this is called a Udeometer, or Udeometer if you pronounce it the way it's spelled. Now, we're going to want to react magnesium with hydrochloric acid. We want to collect this gas. In order to collect the gas, the Udeometer is going to have to be upside down and filled with water, and it's going to be upside down in a giant cylinder of water. Okay, so this is going to have to be filled with water. So what you're going to do is you're going to fill it up, turn it upside down, put your finger over it, and put it underneath the level of the water in the cylinder. But what you need to do is you need to be able to get the reaction to happen all inside of here without losing any of your hydrogen gas. So you have to set it up beforehand with hydrochloric acid. So HCl is going to be right here. And we'll tell you in class how much of that to use. So you have hydrochloric acid. You're going to put that in first. Then you're going to fill the rest of this with distilled water all the way to the top. So there's going to be distilled water. Then what you're going to need is you're going to need your magnesium. But you don't want to just drop your magnesium in, because then it'll react with the hydrogen before you, the H+, before you turn it upside down. So you need to suspend your magnesium piece right here with a string, and then you put your stopper in to hold it in place. The stopper has a little hole in it because you need to be able to allow liquid to come out of the stopper once you put it upside down. So of course, before this, you have to get the grams of magnesium. All right, so grams of magnesium. You're going to need that first on your data. The volume of the HCl is not that important because the limiting reagent is the magnesium. So you're going to put your finger over the stopper. You're going to turn it upside down. Put your finger below the surface of the water and get this whole thing inside the cylinder. So now your magnesium is down here. Your HCl is originally up here. And your water distilled is down here. So what's going to happen is the HCl is more dense than the water. So what's going to happen is the HCl is going to basically swirl down and go down into the magnesium and react with magnesium, forming bubbles of hydrogen, which will go to the top. And then once you're at the top, it's going to push water outside, and it'll go into the giant cylinder, which is fine. So at the end of your reaction, you'll know it's over because there are no more bubbles coming. You're going to have your upside down Udeometer. You're going to have your level of water somewhere, let's say over here. This is all going to be filled. And then inside of here is going to be your hydrogen gas. So your hydrogen gas is going to be up here. But remember, not only will you have hydrogen, you're going to have water vapor as well, because this is collected above water. What you're going to want to do when you read the volume is to make sure these levels are the same. That means that the pressure inside and outside the Udeometer are the same. Now let's go through and figure out how to know each of the variables for PIVNER. Let's start with moles. Moles is going to be the easiest thing. We need to know the moles of the hydrogen. So the moles of the hydrogen is going to be equal to the moles of the magnesium. So you have to know the moles of magnesium, and then you use the bridge or proportions. That divided by 1 times 1 is that same moles of hydrogen. You can assume 100% yield. So from the grams of magnesium, you're going to find the moles of magnesium, and from the moles of magnesium, you're going to find the moles of hydrogen. So when we do our equation, I'll just write up here, PV equals nRT. We're going to know the moles from the moles of magnesium. Okay, so these are the moles, we got that. We're trying to find R, of course. This is what we're trying to find. Okay, temperature is going to be fairly simple because for temperature, all you have to do is measure the temperature of this gas. However, you can't get the temperature of this gas because you can't stick the probe right in here. So since this gas was bubbled through this room temperature water, you're going to get the temperature of the water. And that's going to be your Kelvin temperature. It changed to Kelvin, of course. All right, volume is going to be fairly simple because with volume, all you have to do is read the level of right there in the Udeometer. So the volume is going to be, of course, in liters, and that's going to be from the Udeometer. The last part is the pressure, and that's the tricky part. Okay, for the pressure, you have to understand that the pressure inside is going to be this, inside here is going to be the same as the room. However, the difference is that the inside pressure has two gases. It has the hydrogen and the water vapor. So what you're going to do is you're going to read the room pressure, which is like the total pressure inside here, because the outside pressure of the room is the same as the inside pressure of the Udeometer. But then, of course, you have to look up the vapor pressure of water and subtract that to get just the pressure of the hydrogen. So to get the pressure of the hydrogen, you're going to need to get that into ATMs. Good. And then you're going to convert it, of course, from millimeters of mercury or whatever it is in kilopascals. And then you're going to solve for R, and R is going to be liter atmospheres per mole Kelvin as your unit, because those are the units with which you found R. Liter atmosphere per mole Kelvin. Lastly, you're going to find the molar volume of the hydrogen at STP. So all you need to do is do a two-condition problem. P1V1 over N1T1 equals P2V2 over N2T2. Take all of your room information that you just used up here to find R, put that here. Then you're going to put in all your STP information for what's the pressure at STP. It's for 1 mole at STP. What's the temperature at STP? And you're going to solve for V2, and hopefully you're going to get for this 22.4 liters. And for this, of course, you were hoping to get 0.0821 liter atmospheres per mole Kelvin. That's the lab we're going to be doing tomorrow.